All good? In that case, let's continue on with that. All right, good. Now, that basically allows us the ability to leverage the capability of translating my internal devices going out based on port numbers. Let's say the address that has been assigned to me by my ISP is a Class C address, which is a luxury in today's day and age. It generally will not. But I have a whole bunch of different devices that want to go out simultaneously. This single pool of 254 valid addresses will not suffice. Okay? So to get a better, how should I say it, connectivity, based on a smaller portion of IP addresses, I use the port numbers to make a unique translation entry in the translation table. So for example, let's say I had 10.1 trying to go out to the internet, but I've already used up about 150 addresses for, that was 192.1.20.51 to 200 simultaneous addresses for the network 10.11.11.0/24. They're gone already. Now what I want to do is I have another subnet that also wants to go out. So what I can do is I can dedicate a specific address, let's say 192.1.20. Let's say 41, and I'm going to use this address, a single address, to translate multiple internal IPs to the same one. The way it's going to do that, now you do that for 10.1.1.0. The way it does that is by taking a look at the port number and using that as part of the translation entry. Let's take a look at how it works. So let's say I have 3 IPs, 10.1.1.5 host, 10.1.1.6, and 10.1.1.7 wanting to go to the internet. The packet comes in into your firewall as 10.1.1.5 destined to some address on the internet. 10.1.1.6 destined to another address on the internet. 10.1.1.7 destined to another IP address on the internet, some other address. The firewall receives it. The firewall needs to send a packet out using a public address. And in terms of my pool, I don't have a pool. I just have assigned a single address to the translation. If I do this translation just based on an IP to IP, I'm going to run into an issue. What is the issue that I'm going to run into? Not enough, not just enough. One is going to take it up. How do I translate 2 IP addresses to the same public address? All right. So what the firewall does, whenever you specify a single address to be mapped over to multiple internal IPs, it automatically will pick the source address. You guys know when a packet wants to go out to the internet, let's say it's going to the web server, it's going to have a port number, a destination port number. How about the source port number? It's random, right? So let's say the random port number over here is 21111, 21,111. And this random port number over here is 19.1.1.1. So what the firewall does, it allows the packet to go across. So this packet going out, the first packet from 10.1.1.5, when it goes out, it translates 10.1.1.5 to 192.1.20.41, destined to 199.1.1.1. But in terms of the port numbers, it keeps the port numbers there as is, 21111, destination is port 80, but it keeps that in the translation table. So he's going to have 2111 over here, 2111 over here. So it knows 20.41 is going to be translated to 10.1.1.5. If the packet comes back, destination 20.41, 21111, it will be translated to 10.1.1.5. So the uniqueness is the port number, because the second packet that's going out, it is also going to have 192.20.41, destination of 200.111, but the port numbers are going to be what? A different port number. So over here, what makes the entry unique is the IP and port number combination. So if you take a look at this port number combination, although it's the same IP, but the port number will tell it when the return packet comes in. If it's destined for 2111, use 5. If this is the port number, use 6. But what if, technically speaking, these are randomly generated port numbers by different devices? Is there a possibility that 10.1.1.7 or 17 picks up the same port number as the first one? Possibility? Yeah, because these are two separate devices. So if that happens, I cannot put, my original was like that, 2111. I cannot put this entry over here because now it becomes a duplicate entry, exactly the same. 20.41, 20.41, 211, 211. It's the same exact number. If it sees that, the firewall sees that, it automatically, what it does is it changes not only the IP address, but also the port number. So that packet will look like this. It doesn't change it on the original, but the translated packet that's going out will not only change the source IP, it'll also change the port number to something that has not been used. Let's say 15,001, port 80. Now this makes it a unique entry, and when the packet comes back in destined to 20.41 for 15,001, it's going to change the destination IP to 10.1.1.7 and the port number to 2111. This is in the translation table. In the connection table, it'll be the original. Got it, Mo? Good. Which part, Sammy? I said the connection, the entry will be in the translation table. The port number information will be in the translation table. The connection table will keep the original address, 10.1.1.7 and 2.1.1. It doesn't keep the public address, the translated address. It keeps the original address. Now, how do I configure it? Requirement. Before that, PAT, dynamic PAT, allows multiple internal devices to go out to the internet using a single common IP. The translation table uses the source randomly generated source port number in the translation table to keep the entry unique. In case two internal devices use the same random source port, the ASA will change the source IP and the source port number in the outgoing packet to keep it unique. All right, configuration wise, requirement, the network 10.1.1.0/24 should be able to go out using a single public IP of 10.41. How do I do that? I don't need to create a pool over here. I just specify object network, net, that's just a name. The network, the subnet that I want, NAT, the two interfaces, the high, the low, dynamic. When you put a single IP over here, it automatically knows that you need to do that. Check the title of lab. Sorry, configuring dynamic path. When you use a single IP over here, it automatically knows to do path. So you don't need to worry about it. Or if you want, you can even use the outside interface for path. So for example, if I wanted to do this, I can also use this. This is called interface path. So sometimes you might not know, or you might have just a single address on the WAN site, and that's the address that you want to use. You can use a keyword interface. Interface, they'll pick the IP address from the interface that corresponds to this address. Remember, I told you this goes with this, and this always goes with this. This address on the inside will be translated to the outside interface. You can do that as well. Both options are available to you. Let's do this over here. Copy. Let's go to the ASA firewall and configure the translation. Now to make it work, let's see if it works. Show IP interface brief. I'll do a telnet based on telnet to 199.111. Source interface is going to be loopback 0. Loopback 0 over here is 10.1.1. So when I go out, I should be dynamically patted over to the IP address of 40.192.1.20.41. Take a look. I logged in, show users, shows me 20.41. Not only that, if I go over here, show xlate, TCP pat 10.111.27380, translated to 20.41.27380. So it uses the randomly selected source port number. There you guys, everybody okay with that? Connection table keeps the original. That's what I was talking about in terms of your question. I think Mo, you asked, right? That's dynamic.